Okay, hello, good afternoon. Please, can you hear me? Hello, Kingsley. Can you hear me?
Yes, sir.
Yes, sir.
Okay. Okay, so today we're going to look at the other part of differentiation, and then we'll end with the integration. If you're able to look at all the properties of differentiation, then we can also use the reverse to integrate. So I'm going to go through some examples of the types of different, and then we'll also look at the formulas for integration. And then we'll try and share some worksheets for you to try. And like you recommended, I've extended the time on the submission platform, so you can relax and do it when you are done. Okay, so I'm going to share. I promise I will send the PowerPoint. Unfortunately, yesterday I don't know, I had a power fluctuation. I lost everything, so I'm going to use my Excel. Hopefully, when I have time, PowerPoint takes time to create. So when I have time, I'll create the PowerPoint and also upload it. Okay, so if you have a question, please let me know. Then I go over. Okay, so last week we started looking at differentiation by first principle. Okay, so we understood that when you ask to find if a function is differentiable, then it means that it can be differentiated at a particular point. And these are the symbols that are used to represent differentiation, dy dx, or d dx of a function, or the capital D f of x, or capital D subscript x f of x, or y prime, or f prime of x. All these are differential symbols. Now, we said with first principle, if you happen to have, the way the lines in the Cartesian plane are represented. So if you have a curve and then they are given 2 points and they ask you to differentiate within those 2 points, then we will be using the gradient formula. That means that when you have change in y, the y dx, change in y over change in x. So if we look at the 2 points, our change in y here will be the vertical values here. So we are going to find y2 minus y1. y2 is f of x of h, and then y1 is f of x. So in the numerator here, our numerator becomes function of x plus h minus function of x. And then the denominator will be x2 minus x1. That gives us x plus h minus x. So this is the method in which we apply as h approaches 0, what becomes the differentials of the function. And so last week, we saw how this thing can be done. So an example was if our y is equal to x squared, then our function of x plus h will become x plus h all squared. So if you substitute that into this function, you'll be getting x plus h all squared minus the s squared itself. Now, when you expand that function, you are going to get x squared plus 2xh plus h squared. And then we subtract the x squared from it. Now, that will leave us with virtually this x squared here will take care of this x squared here. And then 2xh plus h squared, if you divide them by h, you'll be left with 2x. So as h approaches 0, you will realize that that x squared function will simply reduce to 2x. So this was an example in using the first principle. Today, we want to continue and look at the other methods in doing this. So first of all, we'll be looking at differentiation by power rule. What do we mean by power rule? First of all, you'll be given a function in the form of y raised to the power, y equals to x raised to a certain power. So if you have any expression written like that, using the power rule, it means that you let the power n come to multiply the function, and then you subtract 1 from the power. So power rule simply means that if I have x squared, it becomes 2 times x, and then the square becomes 2 minus 1. Okay, so let's take an example like this. Sorry, I'm using an Excel which I use for the IT class, so I have not edited some of the functions. So please forgive me for these things. I'm not supposed to be here. Let's go on. If we have y, if you look at this, it means that this is y equals to 4x. X power 1 multiply 4, we're going to get raised to the power 1 minus 1. What is 1 minus 1? Is it not 0? And if that gives us 0, then it means that x raised to the power 0 gives us 1. So my function will reduce to the answer to be 4. Okay. And second example, 4x squared. So it means that here we are going to have 2 coming to multiply 4. So we have a 2 coming to multiply 4x, and then x raised to the power 2 minus 1. So finally, this should give us 4 to 8x raised to the power 1. Okay. The last example for power rule here is if we have 4x raised to the power negative 2, then from the power rule, negative 2 will come to multiply the function 4, and then x will be raised to the power negative 2 minus 1. Okay, so that should give us negative 4. Sorry, it's not negative 4. 4 times negative 2, that gives you negative 8 x raised to the power minus 3. And I hope you know that minus 3 simply means that should be 8 over x cubed. If you want to write this as this should be negative 8 divided by x raised to the power 3. Any questions so far? Can I assume that given a problem, you can be able to differentiate using the power rule? Is everybody okay? Okay, Kingsley said, Kingsley, have your hand up, yes?
I said the 3, I want you to start it again because we started with x is equal to 4x index negative 2.
Yes.
Where we got this negative 2 after the dy dx is equal to the negative 2. I want to know where
Okay. So you remember that is a power. The formula says that if it's raised to the power n, then the n comes to multiply. So this power negative 2 here is what came to multiply the function, negative 2 times the 4x. And then I reduce the power by 1. So minus 2 minus 1. I hope you see it now. The negative 2 is coming from...
Which is indices, right?
Yes, the index is the exponent. The exponent comes to multiply. So if the exponent is negative, then it becomes negative of that now. If it is positive, then just the exponent value. Okay. So the first one like this, you're welcome. The first one like this, the exponent was 1. The second one like this, the exponent was 2. And then the third one, the exponent is negative 2. So all of them comes to pre-multiply, then you reduce the power. Okay, so Is Engineer Philip around? I haven't heard his voice. Okay, let's go on. Then we have what we call differentiation by product rule. Now, it means that you'll be given a function such that there are two functions that are multiplying. So if they are multiplying, we will assume that u is f of x, and then v is g of x. Now, the product rule says that you will keep one of the functions constant and differentiate the other. So keep u constant and differentiate v, plus you keep v constant and differentiate u. Okay, so product rule, you keep one of the functions constant and differentiate the other. I don't know whether you follow. So I can continue and rewrite this as, this is the same as we are keeping, so if u is f of x, it means keep f of x constant, and then you differentiate that of g of x. And how do you differentiate g of x? So that g raised to the power 1, g of x of the function, and then you come and now keep g of x and differentiate f of x. So you keep g of x constant, and now rather you differentiate f of x. Okay, so this is how we approach product rule. So let's look at an example. These are my u and v. My first function is 2x plus 3. My second function is 4x squared minus 2. And then the question says, differentiate this function. Now, somebody will want to go to the, what we call the old school. Old school method would have been, it would have expanded this. You could expand this. It will give you a polynomial to the power 3, so that then your function will be in terms of power rule here. And your function will look like something like this. So something to the power 3, something to the power 2, and then we use power rule. But knowing that if two functions are multiplying, and we can see that they've been written in a factored form, then we can use this formula that we have here. So u is 2x plus 3, and then v is 4x squared minus 2. Okay, so I'm going to keep u constant, that is 2x plus 3, and then I differentiate this. Now, please, this one, you know what the power rule will do. Okay, so I'm going to do it, and you help me do that. When I differentiate 4x squared from the power rule, what would that give me?
8x.
8x, exactly. Okay. As for the constant, when you differentiate the constant, it goes to 0, because constant is actually negative 2x to the power 0. And anything to the power 0 comes to multiply, that disappears. So when you differentiate the constant, that goes away. Now we are going to keep the v function constant, that is 4x squared, minus 2. And then we differentiate 2x plus 3. Now, if I differentiate 2x, what do I get? The power there is 1.
2.
2, exactly. Okay, so now if we simplify, we simply are going to get the 8x will multiply 2x. That is going to give me 16x squared. 16x raised to the power 2. And then 8x will multiply 3. 8, 3, 24. So plus 24x. So that takes care of this left-hand side. And then the right-hand side, I'm going to get plus 2 multiplying 4x, x squared. That is going to be 8x squared. And then 2 multiplying negative 2, that will give me negative 4. Okay, so we can continue and group like terms, simplify, and do all those things. Okay, so 16x squared plus 8x squared, 16 plus 8. Is it not 24? So that gives us 24x raised to the power 2. And then for the x term, we are going to get 24x. And then the constant term is going to be minus 4. Okay, so that will be our final answer at the end. This will be the result when we use the product rule to do this. Okay, so all we are being asked to do is to keep one of the function constants and differentiate the other. And then you keep the other function constant and also differentiate the one that is left. Okay, so let's try the second example. The second example, we have this whole function here. This is my u, and this function here, and that is supposed to be my v. Okay, so we are going to keep that constant, 4x. So 4x raised to the power 3 minus 3x, then plus 2. I'm keeping this constant. Now, if I differentiate 2x squared, what would that give me?
X.
I'll get 4x. And then if I differentiate 4x, what would that give me?
4.
4. Okay. So 4x plus 4. Now I'm going to keep rather 2x squared constant. 2x squared constant. Plus 4x. And then I'll now differentiate the first function. So when I differentiate 4x to the power 3, what would that give me?
12x squared.
12x squared. Yes, 12x squared. 12x squared. And then when I differentiate negative 3x, wouldn't it be minus 3?
Yeah.
Okay, minus 3. Okay, so like we did for the first one, we are supposed to expand and simplify. I hope that we can all do that. I'll do and leave the grouping for you to continue. Okay, so 4x will multiply 4x cubed. That will give us 16x to the power 4. And then we have 4x multiplying negative 3x. That will give me negative 12x to the power 2. And then 4x multiplying times 2. 4x multiplying 2, 4, 2, 8. So that gives me 8x. So that will take care of 4x multiplying the whole of this function. Now we are left with the function, the value 4, to do also likewise. So 4 multiplying 4x cubed, that is going to give me 4x cubed. Sorry, 4, 16x cubed. 16x cubed. And then 4 multiplying negative 3x, that gives you negative 12x. And then plus 4 multiplying the value 2, we get 8, plus 8. So we have expanded this whole thing, and it gave us 16x to the power 4, 12x squared, 4x, 16x cubed, 12x, and plus 8. Now let's look at the terms on the right. It's a long thing. So now we are multiplying this. Supposedly, we're also going to get some x to the power 4. So 2x squared times 12x squared. That is going to give me 12 to 24 x raised to the power 4. Okay, 2 plus 2 will give me 4. And then I have 2x multiplying negative 3. That gives me negative 236, 6x to the power 2. Then I'm done with the 2x. Now I'll take 4x to do the same thing. So this 4x multiplying 12x squared, 4 times 12 is 48. So that gives me plus 48 x to the power 3. And then 4x multiplying negative 3. That will give me 4, 3, 12. 12x raised to the power, just 12x. Okay, so everything is now, so you have to now group your like terms. We are going to add 16 to 24. Okay, that will give us, is it 30 or 40? I think 40 x to the power 4. Then we will follow that with 16x cubed and 48x cubed. Then you group that. Then you come to the x squared term. You group that one as well. And then you come to the x term. And then you come to there's no constant term. Okay, so let me leave the grouping for you. We are only interested in being able to approach this using the product rule. So unlike the power rule, when you are giving functions that are multiplying, keep one constant, differentiate the other, keep the other constant, differentiate the first one. Okay, now let's look at the third example or third rule. Now we are differentiating using the quotient rule. So it means that you will be given an original function. There will be a numerator and there will be a denominator. Obviously, the numerator can be f of x, your denominator can be g of x. Now this time, you will keep the denominator first, okay? So pick the denominator and differentiate the numerator, okay? And then you subtract. This time you are not adding, you subtract. Now you keep the numerator constant and then differentiate the denominator. So v du dx minus u dv dx, and then all divided by the denominator squared, okay? So quotient rule is a little bit different, but the same thing works. I have a very simple example here. My numerator is x plus 2. My denominator is x plus 4. So remember the rule. I'm going to keep the denominator constant. So x plus 4, I'm leaving it constant, and I differentiate the numerator. The numerator, the only variable of x is this x value. And if you differentiate x, you get 1, because the power is 1. 1 minus 1 will give you 0. Minus, now we keep the numerator constant, x plus 2 constant, and then we differentiate the denominator. My denominator is x plus 4. And if I differentiate that, I'll get the value to be 1. Okay, all divided by the denominator x plus 4 all squared. Now let's expand the numerator. So we are going to get x plus 4 minus x minus 2. I hope you know that when I open the brackets, this plus will become minus. Now the denominator will still remain x plus 2 all squared. Okay, so what will be my numerator now? So x minus x goes away. X minus x will go away. I'll be left with 4 minus 2. So the numerator becomes 2, and the denominator becomes, if you want to leave it like that, leave it like that, or you can write it in a quadratic form. So x squared plus 2x. Is it plus 2x? No, it's not 2x, plus 4x. And then plus 4. Okay. So when you differentiate this function, we should get something similar like this. One more example. This time my numerator is 4x minus 9. My denominator is 2 minus x. Okay, so remember, Ernest, your hand is up.
Yes, sir. So good afternoon. In the first example, the vein, is it not u x plus 4?
Yes, the v is x plus 4.
You like the
Yes,
second step.
v is... Are you okay?
That place. Is it supposed to be x plus 4?
So, you mean that...
Yeah.
Oh, sorry. Yes, you're right. You're right. So it's x plus 4 squared. So this should be 4x plus 4. That should be 8x. Sorry about that. Okay, thank you for the correction. So x squared, 8x, and then plus 8. Okay, so now let's look at this example. The denominator here is 2 minus x. So keep the numerator constant and then differentiate the numerator. If I differentiate 4x, I'm going to get the value 4. And then now I'm going to keep the numerator constant. This is 4x minus 9. And then differentiate the denominator. If I differentiate the denominator, I'm going to get -1. Okay, remember that this is 2 minus x. 2 minus x, the power is 1. So if the 1 comes to multiply this, I'll get -1. Then the denominator 2 minus x all squared. When I expand the numerator, I'll get 428 minus 4 times x is 4x. And then on the right-hand side, I'm going to get, okay, -1 multiplying -4. That will give me positive, this is supposed to be positive 4x, okay? And then this -1 multiplying, remember negative. First of all, you can multiply by negative. There will be negative in front here, there will be positive. But because of this negative, this will become positive. -9 will give us +9. Correct. All divided by 2 2 minus, so that should give you 224. Okay, let me leave it like that. So 2 minus x all squared. Okay. Okay, I just want to check this. So -1 times this would have given me -4. Okay, this would have given me -4. This -1 times this would have given me +9. Okay, so if the negative now outside comes in, this will be +4, and this negative comes into this +9, I'll give me -9. Okay, I hope you see what I've just done. So this is right. Now, evaluating this, the numerator will now reduce to -4x and +4x is going to reduce to simply x will disappear. I'll be left with 8 minus 9. That will gives me -1. And then the denominator, I think you are supposed to get x squared, -x, x squared. This will give you -2x. So that gives you -4. Sorry. That gives you -4x. And then all plus 4. I think that should be your final answer. Okay, so all these problems, when you see them, just remember the rules that apply. Then we use them. Okay, now let's look at the chain rule. The chain rule. So chain rule is when you have a function raised to another function, like composite function. Is it f into bracket g of x? So there is a function within a function. And most of the time, it is when, let's say, you have 2x plus 4, all raised to the power 4. Okay? So 2x squared plus 4, all that is raised to the power 4. So within a function, you have another function. So this is the power rule. The power rule says that there are two methods. First of all, you first of all differentiate the function, okay? f prime of the function, and then come and differentiate the function inside. In other words, do dy du. Let one of the function be equal to f of u. So differentiate respect to u, and now differentiate u with respect to x. So dy du dx. An example will help very well. So all we are saying is that if I let this function to be equal to my u, okay? So first of all, I'll differentiate this function with respect to x. That is why I'm saying that, first of all, do du dx. So this is my u. If u is equal to this, du dx will be differentiating 3x plus 2. If I differentiate 3x plus 2, I'm simply going to get, I don't know why I did fraction here. This is not supposed to be a fraction. If I differentiate 3x plus 2, I'm going to get the value 3. Okay, so I'm going to get 3. And then we differentiate the function itself. So if I differentiate, if I let, what I'm trying to say is this: if you let u to be equal to 3x plus 2, okay, let u be equal to this, then it means that that function there is u raised to the power 4. I hope you see it. It means that this function is simply going to be u raised to the power 4, because I haven't formatted this. So this will be u raised to the power 4. Okay. So first of all, the value says that differentiate y with respect to u. So dy du. So if I differentiate this function with respect to u, I'm going to get 3. And then I'm going to differentiate the function of u itself, du dx. This will be 4u raised to the power 3. So if I differentiate 3x plus 2, I'll get 3. Now come and differentiate this function u raised to the power 4. Is it not going to be 4, a value 4, into bracket 3x plus 2, or then reduce that power by 1. Sorry, power. So 4 minus 1 is going to give us 3. Okay. So first of all, I differentiated the function itself, 3x plus 2. It gives me 3. That's the value here. That's the f prime. You see, that's the f prime of the function. Then I repeated 3x plus 2. And then I differentiate the f prime of x itself. So this whole function, if I differentiate with respect to 4, 4 comes to multiply this whole thing and reduces this by 1. So this finally should give us, this should give us 4, 3, 12 into bracket 3x plus 2 all raised to the power 3. Okay, 3x plus 2 all raised to the power 3. Okay, so let me verify from the material we are using. Okay, I hope you are using the material that is online. Some of these examples are coming from that material, so that's what I'm referring to. So this example, I picked it from that material, just to confirm what I'm saying. This is a question that we just solved, okay? I hope you can see from your screen. Let me magnify this a bit. Okay, so I didn't have time to do all this in the Excel. So first of all, what did we do? This was a function, 3x plus 2 raised to the power 4. So we are saying that if we let u be equal to 3x plus 2, what is du dx? That gives me 3. And then what is dy du? That gives me 4u to the power 3. So this is supposed to be du dx times dy du. So the answer you got here as 3, going to multiply the 4u to the power 3. Now then you substitute the value of u. The value of u is 3x plus 2. Okay, so 12u to the power 3 by u is 3x plus this, which is exactly what we got. Okay, so if you don't like this method and you like the function of x method, it says, first of all, differentiate the function, the original function, with respect to x. Now, if I differentiate this with respect to x, you know that this 4 will now come to multiply the function. So 4 comes to multiply the function and reduce 4 by 1. And then come and differentiate the function itself. And if I differentiate 3x plus 2, I'm going to get 3x. When you expand, it will all give us the same example, the same one that I got in the Excel. So that example was typically from the notes. Okay, so composite function, all you need to do is differentiate with respect to the function or differentiate with respect to the power, and then come and differentiate the function. So we differentiate with respect to the power 4. The 4 comes to multiply here, and it gives us to the power 3. And then differentiate 3x plus 2, and that will give you 3. That, I'm sure, will be easier. Now, let's try this one. Let's try this one. Maybe do this with me. If I differentiate the function with respect to the power, again, I don't know why I have half here. If I differentiate the function with respect to the power, I'm going to get half coming to multiply. And then the original function will reduce by 1. So I will get 1 plus x raised to the power 3. Okay. And then the power will reduce by 1. What is half minus 1? Half minus 1, what do they be? Is it non-negative half? Somebody confirm for me. What is 1 over 2 minus 1? That is 1 over 2 minus 2 over 2. That will give you negative 1 over 2. Okay. So the first part of the work is I differentiate this function with respect to the power. The power comes to multiply and then reduce the power by 1. Now I have 1 plus x cubed. Differentiate this with respect to x. So if I differentiate this function with respect to x, what will I get? Is it not 3x squared? The power x cubed will give me 3x raised to the power 2. Okay? And if you want to simplify further, all you can do is multiply half by the 3. I think that's the only thing you can do, and bring the x squared in front. So half times this will give me 3 divided by 2. Then into bracket 1 plus x raised to the power 3. All this raised to the power negative half. In other words, if something raised to the power negative half, I hope it means that you're finding square root 1 over the square root of that function. But let me leave it in the form of exponent, 1 over negative half. Okay. So that is how to use what we call the chain rule. So one after the other. You do one, then you continue doing the others. So what if you have a function within a function, like composite function, f not of g, not of h? Then you continue doing this. You keep one constant and differentiate the other, and then come and differentiate the other with respect to the power that is given. And then you'll be able to have your results. I don't see a hand up. Any questions? We are now getting to logarithm functions, and then exponential function, and then we can take some more tutorial questions on this. Okay, so how do you differentiate log functions? Let's start from exponential functions. Exponential functions are given the form of y is equal to e raised to the power x, or y is equal to e raised to the power constant multiplying e raised to the power x. Now the rule, by the way, that e is a constant on the calculator. Is I think the Euler constant or so. When you differentiate with respect to x, an exponential function, if it's e of x, the answer is e of x. That's one beautiful thing about exponential function. But in general, if this x is being multiplied by a constant, then you differentiate that x in general. So let's say that our y is equal to a multiplying the e. So the a is there, but the e is raised to the power r of rx. So there's a constant multiplying the variable x. So this is a formula. First of all, you keep the constant in the original function, and then differentiate r of x. Okay, so keep the original function and then differentiate the power r of x. If you differentiate r of x, you will simply get r because x is raised to the power 1. So basically, all they are telling you is that if you have an exponential function, and the power to which that exponential function is raised to, that power, you differentiate that power if it's in terms of x, and let it multiply the original exponential function. Okay, so what will this be? What will this be? This one, I think you can tell me. What is e raised to the power 2x? If I differentiate this, what should be my answer? Based on the rule. When you differentiate 2x, what do you get?
So you get 2.
You get 2. Okay, so that gives you 2. And then you repeat the function again, e raised to the power 2x. So it's as simple as that. Do I have any more example? Exponential functions, they are very, okay. What about e raised to the power negative 7x? Again, if you differentiate negative 7x, you are going to get negative 7, I think. So that should be negative 7. And then you repeat the function e raised to the power negative 7x. So exponential functions are that straightforward. Okay. If they want you to leave your answer in forms of inverse, you can do that. But if you are given logarithm function, by the way, logarithm function here, we are talking about log to base e. So normally we call it the natural log. No, this function is called the natural log function. On your calculator, it's written as ln, natural log. So if y is given as natural log of x, that is log x to base e, then it's written as ln x, or natural log of x. Now, so let's assume that this ln is a function. So when you have to differentiate it, you differentiate the variable. So if it's ln 2x, you differentiate 2x. If it's ln x squared plus 4, you differentiate x squared plus 4. Okay, so this is a formula. You are going to get a fraction. Actually, when you differentiate ln x, you are going to get 1 over x, because when you differentiate this x, it's going to give you 1. So 1 over ln x. Okay, 1 over x, because x is my g of x. I hope you are following. If I differentiate natural log of x, if I differentiate x, I'm going to get 1. And then g of x is x. So my answer will be 1 over x. But if I am given something like x cubed plus 1, okay, so first of all, let's differentiate x cubed plus 1 in the numerator. I'm going to get 3x raised to the power 2. 3x raised to the power 2. When you differentiate 1, you get 0. All divided by the g of x. Remember, the g of x is a term in the brackets. So that is the x cubed by x cubed plus, plus 1. Okay. So you differentiate that, this is what you should get. Now, what about this? Here, this question is a bit loaded. This time, it's not just ln x. It is x cubed multiplying ln x. And I've written here that remember product rule. Do you remember product rule? Product rule, you keep one constant and differentiate the other. Okay, so here, what do we keep constant? We are going to keep x cubed constant. So x raised to the power 3 constant. And then differentiate ln x. Remember, if you differentiate ln x, you are going to get 1 divided by, this thing. I need a space in between this before it will work. 1 divided by x. Okay, so that is for keeping u constant and differentiate v. Now we are going to keep v constant. My v is ln x, so plus natural log of x. Oh, I didn't anticipate this. So natural log So we are going to keep natural log of x constant, and rather we will differentiate x cubed. And if you differentiate x cubed, that is going to give you 2x raised to the power 2. Okay, so I mean, functions like this, you can't simplify them further. All you can do is to rearrange your answers. So x cubed multiplying 1 over x will simply give me, I think, x to the power 2. So x raised to the power 2. And then the term on the right, you just rearrange it. Natural log of x multiplying 2x squared. So you can write it as 2x raised to the power 2 all times the natural log of x. And that should be the differential of this exponential function. Okay, so today we've seen several examples. The last part of the lecture is the integration. And for that, since we've done so much about differentiation, I am very sure just looking at these formulas, you can be able to solve problems with integration. I didn't have time to put any of these questions in the Excel document, but so if you want to integrate, remember, this is the power rule. This is a power rule for the first one. If you want to differentiate xn, it becomes xn minus 1. That is what we use, the first one. But if you want to integrate xn, please look at the formula. This time you add 1 to the power. So x plus 1 divided by n plus 1, all plus a constant. Okay? So when we have on the left are the differential functions, then on the right are the integral functions. So we've gone through power rule and all that. And to integrate, you just integrate the function. You let the power of the function be increased by 1 and divide by that increase. Then you add a constant. Why we are adding constant is because we call this indefinite integrals. Okay? If they give you a problem and then they ask you to find the values of the definite integral, then we will put the limit into the integration function and it will give us a solution. I'm going to try and use a calculator to show you how to do some of these things before we go. Now, the rest are trig functions. As for trig, we've done a lot of trigs. We know when you the properties of trig, but there are the differentials of trig function. When you differentiate sine, you get cos. When you differentiate cos, you get negative sine. When you differentiate tan, you get sec squared. When you differentiate cot, you get cosec squared. But when you differentiate sec, you get sec and tan. Some of these things are called standard integrals and differentials. Okay, so while you are differentiating, if you are practicing differentiation of trig functions, you should also look at their integrals. While sine is giving us cos, when you integrate cos, it gives us sine. So it's a reverse. If I integrate cos, I should get sine, but you add a constant. And therefore, if differential of cos is giving you negative sine, then it means that integral of sine will give you negative cos. I hope you see the trend. When the values are positive, when you differentiate sine of x and it gives you a cosine of x, that means that when you integrate cosine of x, it should give you sine of x plus a constant. And if you differentiate cos of x and gives you negative sine, therefore, when you integrate sine, you should get negative cos. Okay, so the rest, I think sometimes we are allowed to give you the standard integrals in the exams. So we may do that so that you don't have to memorize all these popular integrals. Okay, so integration of sec square will give you tan x. Integration of cosec square will give you negative cot x. And integration of sec and tan will give you sec of x. Okay, so these are the standard integral functions that you are supposed to be familiar with. Okay, so what I'm going to show you right now is the questions which I'll first of all send it to Eric, but I'm going to place them on the LMS as well. The first part is because we are ending with integration, I will want to show you some examples of integration. I haven't been able to put them in the Excel, so let's try it. Let's try them out together and see whether you follow. Then I will take definite integrals using a calculator to see the difference. My questions and my tutorial questions are a lot, but please, the idea is even if you can't solve all of them, okay? The idea is that even if you can't solve all of them, you can solve one out of every group. Okay, if you are being burdened with the timelines and the submission timelines, remember these things, if we're meeting face-to-face, we will do them physically in class, but we are supposed to give you as many examples as possible so that when we are not meeting, at least you know you can be able to do some things. Okay, so let's look at this integral functions. They're asking you to integrate x squared. So remember the power rule. The power rule says that if the power is n, then increase n by 1 and divide by that power. So who can help us with this? When I integrate x squared, what should that give me? It will be what? What over what? My n is 2. Any volunteer? Or you want me to go there and try one before we come here?
Yes, sir. Yes, sir.
Okay. So let's go back here. Let me copy this function. Okay. So if you are given we're given x raised to the power 3. Okay, given x raised to the power 3, and this is supposed to be integral of a function. So integral of a function is written as this. So this will be x to the power 3 dx. This is how integral functions are. Now we said from the formula. Remember the formula at the top. This formula. If you have x raised to the power n, x raised to the power n dx, then you add 1 to the power and divide by that power. So that is basically what I'm going to do here. So to integrate this, I'm going to get x. First of all, let me create a fraction. So this is supposed to be x raised to the power 3 plus 1. 3 plus 1. All divided by that 3 plus 1. So finally, this should give me x raised to the power 4. X raised to the power 4, all divided by 4. All this plus a constant. When you integrate, because we are not finding the limits, you should get something like this. Okay, maybe let's take another example. Okay, so let's pick another example from the worksheet. If we have 4x to the power 7, 4x to the power 7, let's try that. So this time round, I have 4x, so 4x raised to the power 7. Okay, so when we integrate that, now, so it means that the numerator, remember 4 is a constant, so That gives you 4x. Then you have 7 plus 1, all divided by 7 plus 1. So the numerator will give you 4x raised to the power 8, all divided by 8. Okay. So in other words, if you want to simplify this further, 4/8 will give you half. Is that not it? 4/8 is going to give you half. All going to that. So the numerator will become x to the power 8, all divided by 2. Because 4 goes into 8 2 times. Okay. So all these questions you have here, is the same thing. You look at the power of the x. You add 1 to the power and divide the function by that power. Okay. Okay, so let's take something more interesting like this. 2x plus 3. 2x plus 3. Integral of 2x plus 3. Okay, so in here, I'm going to have 2 2x plus 3, close brackets, we are integrating this. Okay, so when you integrate the first one, you're going to get 2 x raised to the power 1 plus 1, because x currently is raised to the power 1. So what is 1 plus 1? That will give you 2x squared, and then the denominator divided by 2. Okay, now when you integrate 3, sorry, this should be 2 here. When you integrate 3, remember that value 3 there is x raised to the power 0. I hope you know that 3 will be x raised to the power 0. So this plus 3 x raised to the power 0 plus 1. Okay. Oh, I should have done this separately. Sorry. These are 2 different functions. So all this over 2, then plus all this over 2, then plus a divided by b. So the numerator will be 3x raised to the power 0 plus 1. I hope you saw what I did wrong. So 0 plus 1, all divided by 0 plus 1. Okay, so when you simplify this, this should give us 2x squared. So a divided by b to get a fraction. This gives me 2x raised to the power 2, all divided by 2. And that means that the 2 will cancel 2. If I've seen it earlier, I would have just canceled it. And then on the right-hand side, I'm going to have 3x. So again, a divided by b gives me a fraction. So I have 3x raised to the power 1, all divided by 1. You know, anything divided by 1 will give you 1. So we can let this thing be equal to x squared, all plus 3x. This should be your x squared all plus 3x. So I hope you can follow through and do all the others. Or I should do one more. Yes, please.
Please, what you just did. You didn't add a constant c.
Sorry. It's an oversight. I should do that. The constant should always come at the end, unless they are definite integral. Constant should always be there. Okay, so all these questions you have here, the same thing. If you're able to master the technique, you can do it even without going through all the steps. This will be 3x5 divided by 5. This will be x3 divided by 3. This will be 6x. I hope you can see that. Okay, this will be 3x raised to the power 5 divided by 5. This will be x raised to the power 3 divided by 3. And this will be negative 6x. Now, if you get something like this, either you expand or I think you have to use, if you expand or if you don't expand, if you expand, then it will look like a quadratic like this. Then you integrate. I think that would be the best way. But if you want to use the product rule, the way we have the product rule for differentiation, u dv dx, v du dx, the same thing applies when you come to integration, okay? So it means that you integrate one and keep the other, and integrate the other and keep the first one. The same thing applies when you have these things are product rule. Okay, this one too will be x minus 2, x minus 2. Or expand it, they get x squared minus 4x plus 4. So that it looks like this. Then you can use the chain rule. Okay, so all these functions are supposed to approach them in the same way. These ones, you can change them to indices, and then you can integrate them. Okay, so this is integration with indefinite integral. Then you come across something like this. So this one, I didn't have time to prep myself for this, but let's all do it together. What if the question says that integrate with respect to values? Okay, so this ones, if you can do it manually, please do that. If you can't do it manually, and then you must learn how to use the calculator, and I'll try to see if I can show you how to use the calculator to do that, so that it will save you a whole lot of work. So let me share the calculator on your screen. Okay, so I hope you can see the calculator and then the work. Please, can you see the calculator?
Yes, please.
Okay, so
Yes,
if you are given a problem like this, evaluate the following integrals, and then this time you are given limits. Okay, so you come to your calculator, and then this is the integral function. Okay, so first of all, try and enter the limit in the calculator. Oh, then when you are not careful, to be jumping. Okay, so the upper limit is 3. Then you use the cursor to move the lower limit, it is 1. Now, and now how do we enter the variable x? How do we enter the variable x? Now, where do we ask the x function? Is on, somebody remembers, there's shift something. Where you have A, B, C, D. A, B, C, D. I think it's on the bracket. Do you see x here on the bracket, the closed bracket? And it's in red. So you are going to press alpha and that x. You see that the x now comes. Okay, so I'm going to enter the value of the function. So open brackets, 4x minus 1. Then close the brackets. And then press equal to, and it solves the thing for you. Okay, so if you should see problems like this in the exam, or let's say in your midterm multiple choice questions, then this is how you enter them into the calculator to evaluate them. Okay, so somebody will say, if I don't have the calculator, how will I do this? Then it means that you see this function, you must integrate it. Now, based on what we did a few minutes ago, to integrate this, we'll give you 4x squared divided by 2. I hope the power here is 1. So it gives you 4x squared divided by 2. The 2 cancels the 4. So you get 2x squared. And then when you integrate the value 1, you get x. So 2x squared minus x. Then you put the upper limit into the function, and you put the lower limit into the function. upper limit minus the lower limit, and that gives us the 14. Or you want me to do this manually for you to see?
Yeah, please.
Should we do? We should do it manually.
Yes, sir.
Yes, sir.
Yes, please.
Okay. Okay. So let's go back to the Excel. Okay. So the question was 4x minus 1. Where is my Excel? Okay, so let's pick this function is easier. Okay, so this integral is not definite integral. So I have to go and pick a definite integral. So integration sign that has limits. So something like this. I don't know whether this will work. Okay, so it means that, oh, why did he repeat it twice? Okay, now I can do it. Yeah. So definite integral. Okay, so we have I think the upper was 3 and this was 1. And then this was into brackets 4x minus 1. Okay, and then this was dx. Okay, so first of all, we have to integrate this. We have to integrate this manually. Okay, so if we integrate the first one, we are going to get, remember what we did earlier. So a divided by b. So here the numerator will be 4x raised to the power 2. I hope I can do it directly. That is 1 plus 1. That gives me 2, all divided by 2. And then for the minus 1, when I integrate the value minus 1, I'm going to get x, because that is x to the power 0. So 0 plus 1 will give you 1. 1 divided by 1 will give me that function. Okay, so when you are going to do this, I should have opened a bracket first. Where are my brackets? So I'm supposed to pick a bracket that looks like this. A bracket that has upper and lower limits.
Yeah.
Okay, so all the same. Let me do it well so that you can follow and do it yourself later. 26. Okay, so I think this was the equation. So 4x minus 3. And then this function you have here, this thing, is supposed to have upper and the lower limit. So what it means is that you are now going to substitute the upper limit into the function. Okay, so if I substitute the upper limit into the function, what will I get? So that gives me 4 times, let me use square brackets. So 4 times 3 squared. What is 3 squared?
9.
3. Okay, so 4 times 9. Thank you. Let's do it that way. And then 4 times 9, sorry, it's 4 over 2. Let's do it 2. Please, let's do it 2, because 4 divided by 2, you give me 2. So 2 times 9, then minus 3. Okay, so that will give me the upper limit, all minus the lower limit. So the
1.
lower limit, again, 2 into bracket, that gives you 3. So 2 times 3, sorry, 2 times 1. Is it not? 2 times 1. Okay. 2 times 1 minus, when you put the lower limits into that, that should give you minus 1. Okay, so what should this give us? We know the answer, so if we get it wrong, we all know where we went wrong. Okay, so the left-hand side should give us 9 to 18. What is 18 minus 3? What's 18 minus 3? Is it 15?
40.
Is it 15? 18 minus 3 is 15, isn't it? I'm talking about the 9 to 18. 18 minus 3 is
15.
50. Okay. Now then the right-hand side. This is supposed to be 2, 1, 2. 2 minus 1 is 1. So what is 15? Yeah, 15 minus 1. So we got the answer. The answer is 14. Okay. So this is what I am saving you from. Unless this were to be a subjective question. If it's a subjective question, you have to show working. But if it's not subjective and it's MCQs, then what I am showing you out there is the best approach, so that you don't stress at all doing this. Okay. So back to the questions here. We've done. Hey, did I show 3 things? Supposed to show. What are you seeing on your screen? I'm seeing. Okay, here. So here, these questions we are seeing here, all I'm saying is that take your time, enter them into the calculator, and then they will evaluate. The calculator will evaluate it for you, or you manually must have to do this yourself. Okay, so let's take the D. D is 3. The numerator is 3. So move the cursor. The numerator is 3, and the denominator is 2. And then the function is 3x plus 1.
Okay.
So 3x. So that's 3x. Hey, what happened? Oh, 3x. Is it like this? Okay, 3x, then plus 1. Three x plus 1, all raised to the power 2. So where is my squared? This is my squared. Okay, then you press equal to, and the answer is 73. Okay, so all these questions you have here, well, when it comes to questions like this, because there is an unknown value here, it means that you must integrate and equate it to 18 and solve for A. Okay, so whether it is definite integral, if it is an indefinite integral, then we have to use the formulas that I showed you to be able to integrate. But if it is, that is indefinite. But if it's definite integrals like these examples, then we can use the calculator to be able to solve them. And then the other worksheets, there are 3 of them, but I think I gave you differentials. This is a worksheet I gave you. Simple, this is power function, 7x squared. So that will be 14x. Then this is 3x cubed minus 8. Again, you differentiate, that will be 9x squared plus minus 8. This is 8x cubed plus x minus 4. If you differentiate, that will give you 24x plus 1. Okay. So these are very simple ones here. This will take care of product rule. So this product rule. If you don't want to use product rule, then you expand. And then we have quotient rule. This is a fraction. If you don't want to use quotient rule, then change this to 3x raised to the power negative 2. And then this is both product rule and quotient rule. Right. Okay. So these examples are like, so what I'm recommending is that the worksheets are a lot. And some of these things are supposed to engage you when we are not meeting. But if you are supposed to submit them, please, at least under each of the worksheets, make sure you don't do less than half of the questions. That's my recommendation. Okay. And then this is the second worksheet. These were the ones we started looking at. So again, we are differentiating respect to x. Again, there are a lot of questions here. So try as much as possible. These are how many questions here? It's a lot. Okay. Some of them can be applied in session B in your exams. So I will recommend that at least do out of each of these questions, C1, the first part, if you can take 2 questions from each. I'm talking about submission, okay? Because I had a call about your deadlines, I don't want these things to overwhelm you. There's quite a lot of things that we are learning and a lot of materials. So I'm saying that if you take each of the session, you can do just 2 of them, 2 out of the session, but use the others to practice so that you get familiar with the way the questions are asked. So take 2 out of each of them. Here to take about 2 questions and then submit them. So I'm going to send this to Eric. I will leave them also on the LMS as well, so that you know how to. So 2 questions on differentials, this, and then 2 questions on integrals. Integrals, one will be indefinite integrals, the other will be definite integral. Okay. Okay. So any questions or any comments? By the way, I think the calculator too can do differentials, but you must also, I think, give limits. Okay, you must give limits. So that means that if for example, I give you let's say x, sorry, what did I press? If I alpha rather this, and I give you x squared, for example, let's do x raised to the power 4 plus let's say 3x squared. Okay, then I ask you to evaluate this as x is equal to 4. Then it can do it. It can differentiate it and give you the answer, something like this, 256. But if there's no limit, unfortunately, I didn't give you tutorials on those ones. Okay, so if the function say differentiate and then evaluate the differential at a point, then you can use the calculator to do it. But if it doesn't give you the point to differentiate, then you have to do it manually. The calculator doesn't have memory to write out the differentials and the integrals. It can only do it and evaluate and give you an answer. Okay, so with the calculator, if you are required to evaluate, then you can use the calculator to solve it. But if you're not supposed to evaluate at a point, then you have to use all the techniques we've learned today to be able to do that. Okay. Okay, so I'm dropping this with Eric right now, and then at the same time I'll upload them on the LMS. Today I don't know, Eric, when you found out about the Socrates, what feedback did you get? You guys, why didn't you finish my Socrates 2 weeks ago? The trig Socrates. Have you finished now? Or some haven't still done it?
Still, we have not done it. When I went to it was too late.
It was too late. It means I don't even remember that I've closed it. Have I closed it? Eric, is it working? What's your room name? You remember the room name? Nobody remembers the room name. I would have checked to check whether I have closed it. I doubt if I closed it because your account is only for you. But all the same, if you haven't done it, let me know. I have to activate it for you. So if you haven't done it, let me know so that I do that for you, so that you can make use of this. Okay, so based on what we've done so far, we've done differentiation, we've done integration. So I think what we have left is, let's see. So we are left with, oh, wow, complex of matrices. I have a lot of materials on mass numbers and then vector algebra. So we are left with 3 topics, main topics to treat. So hopefully, God willing, next week we'll look at complex matrices. I have videos I can show it to you, because you are supposed to know how to transpose a matrix, how to add matrix, how to find determinant of matrix. So I'll upload the videos online so that you can watch ahead of. I don't have videos on complex. I don't have videos on vector algebra. As for matrices algebra, yes. Okay, so please watch out on the elements, so that I want to give those things that you can go ahead and do them ahead of time. And I want to share that online for you. There are others, some like complex numbers. I know if I meet you once and we go through tutorials, you can answer the questions. Then likewise, vector algebra. But as for matrices, they are that easy. So I'm sure with a video, you can be able to handle it. Okay, so any more questions? If not, then, okay, that's a room name. Welcome, BEE, Jan 2020. No, that is not a room name. Please, this one is the first, that's the first room name. And when we met in the lab, I gave you a room name. I remember I gave you a room name. And from what I shared with Eric the other time, very few of you have done. I think only 2 people or so. Only 2 people or 3 people have done it. Okay, let's see. BEE, distant learning. I don't remember myself too. BEE. And this is trick. Okay, so this is IT. Yours is okay. So that is your room name. Your room name is Trick Jan 2026. Let me put it in the chat room. ERIGJAN 2026. EISTLEARNDEE. Okay, so if you've done it, there's no need to do it again. Okay, if you've done it, there's no need to do it again. But I've activated it again for you. And then Kingsley, I'm placing the worksheet. So the worksheet is differentiation is 2, integration is also 2. I'll upload them on the LMS as well so that
Okay, sir. So please, this one, is it a new one or the old one?
which one? You mean the Socrative?
Yes, please.
Oh, it's not a new one. It's I'm saying that when I looked at those who did it, it's not all the 15 of you who did it. So those who haven't
Yes.
done the trick, if you haven't done it, then please do it. If you've done it, there's no need to. Please remember the question. It says y is equal to cos this. Find the maximum value of y. If you are given to sine 5 of x, find the period. I hope you remember this. What's the amplitude? What's the greatest period? What is the range? What's the phase shift? The things we did in range again and amplitude. So if you've done this already, there's no need to redo it. Okay. I'm sure the results will be in my inbox. I don't have the reports here. I would have opened it to verify those who did it. But it is in my inbox. I have to go to the inbox to download the results. Okay, so basically that is it. I don't have Socrative for and the differentiation and then the integration. I'll see whether I'll have time. We're supposed to submit exam questions for our regular students by this week. That is why I'm a bit busy, but if I make time, I'll create some 15 questions, MCQs for you here so that you can try them. Okay, so Kingsley, check your WhatsApp. I've dropped the files there. Those who too want it in the chat room too, I'm dropping them in the chat room. Okay, so if you can download it before we log out, that you can also have them on your PCs or on your phones. But I'm going to place them
So please,
also
sir,
in the.
I've downloaded them. I'm sharing it.
Okay, then. Okay. So thanks for coming. God willing, next week, like I said, we will look at complex numbers and I'll send a video on matrices and also some materials on vector algebra. Then I'm sure we will be equipped for the rest of the semester as well. So enjoy the rest of your day and take care of yourself as well. Bye.
Hello, sir.
Yes.
Bye, sir.
Hello, sir.
Bye. Hello.
Sir.
Who is it?
Bye.
Okay, go ahead.
Sir.
Somebody want to speak.
Sir, please, I was asking if you should
Yes,
you
I'm
try our
listening.
hands on. Should you try our hands on it? The ones that you sent to us. Oh,
On which of them? Yes,
therefore.
the differential, the ones that we did today. I'm saying try some 2 questions from each of them.
Okay.
Yes. Okay. Bye.
And say
Thank
again.
you, sir. Thank you, sir.
Say, hello.
Hi.
Oh, fine. Hey.
Hey. Well, fine. Anything.
Yes.
Hey, but your com skills. So, any link we so we have the another link for com skills.
Come screen check. Any the time need them and buy you. I know.
Sure. I got 30 minutes. from
What's
3 to
it?
5.
3 to 5. Ah, okay.
So we can log out now and warm up
Okay.
for the con skills.
Okay. In the what dano?
Masa, can I vote assignment a goose was I dream with that one?